News segment time. The news. We're gonna keep the news short. There's only one article that I decided to pick out, and it's breaking. Like this is fresh. This is
Yeah.
this is fresh as it gets. Are you looking at the screen right now? Or are you looking away?
Yeah, I'm just completely avoiding my phone right now.
Oh.
Kidding.
Oh, okay. Well, anyways, are you seeing? So the Webb Telescope, they have it aligned. And so,
Okay.
what?
Yeah.
And so this is like that. This is like their first photo they took with it. What's crazy?
Oh, so they don't have 18 pictures of the same thing.
No. So what's crazy about this is this star is like it's nowhere near visible to the human eye. But look how bright it is in this photo. It's bleeding into the rest of the photo with how bright it is. That's how sensitive Webb is. And it's so sensitive that see this smudge here?
Mm-hmm.
That's a galaxy. Most of these are galaxies with incredible definition. They're not even trying to look at these. Dr. Becky was oodling over this. Anyways, so then here this looks fake, but this is the pinhole camera selfie thing that they have set up on the web. And this is the old one over here. And so you can see all the mirrors are misaligned and now they're perfect. Which is absolutely crazy. Now, this is only one sensor. This is only like the near visible sensor. This is the one that's in red. They've still got like 3 more sensors to prepare. And I think she said its resolution is 24 times greater than the current space infrared telescope.
Which is Hubble?
No, infrared, not visible.
Well, I thought Hubble did infrared too.
I don't think so. I bet they have better. Well, she didn't mention it, so I'm assuming this other telescope is way better than Hubble for visible.
I see.
Which this is crazy. The way the James Webb Space Telescope is absolutely insane. What it's going to be able to do. I really wish the extremely large telescope was going to be up and running soon, so we could do like comparisons with it. But unfortunately, it won't be ready to go till like what 2030s, I thought. Or no, 2025. That's what it was.
Ways to go.
Yeah. I mean, 2025 isn't as far as we thought, as originally thought, but but like the issue with like I wonder, I was thinking how big of a ground-based telescope can we make? And ground-based telescopes are going to have their limits as we get more and more like Starlink and OneWeb satellites in orbit. So it's like, what's our next move? Where do we go from here? James Webb took decades. It was worth $10 billion, and it's huge. It's massive, but it's nowhere near as big as like the extremely large telescope. And so it's like, can we put a telescope like that one in orbit? I wonder, do you think it's possible to like ship like 10 James Webbs into orbit and like have them like hooked together?
Oh, I don't know.
So like the mirror just assembles itself. I mean, with current technology, it's not possible, but as we are able to get humans into orbit more easily, I think we could send like 10 of these up into orbit, send them out to L2. We send an astronaut crew out there, and they go and assemble this giant behemoth of a telescope, like huge. Like the torque on this thing is going to be stupid. That's going to be the big issue.
Yeah.
And the heat shield. you might as well, because you can't build it on the moon because the moon's gonna be in the sun. It's not constantly dark.
Hmm.
You would need, you would have to build something that's tidally locked with the sun, so that
Yeah.
you could properly do this, which is what L2 is essentially. You're tidally
Hmm.
locking it to the sun.
Yes.
But God, I don't know. It's very science fictiony, but I mean, it's possible. And just imagine. I mean, I don't know. Like, does science need a telescope with that? Like, it would really. All it would be really good for would be searching for exoplanets.
Yeah.
Because we don't really.
And anomalies.
Huh?
And anomalies.
Yeah. Because we don't need it. Because, like, James Webb is going to satisfy looking at the deepest part of the universe. I mean, increasing your resolution by a stupid amount would be awesome, but it's probably not necessary. But the ability to study exoplanets with an even bigger one, that could seem feasible. But I also think with a telescope that size, I think you'd also need something that will allow you to go and explore those other planets, you know? I don't want to invest what could probably be $1 trillion into an instrument if I can't go and explore if I can't go to those places, you know. Hey, look, we found a planet that has intelligent life because of such and such emission lines in the atmosphere of one of the planets.
Yeah.
Great. Uh,
It's 84 million light years away.
that's Andromeda. I mean, we have detected exoplanets in other galaxies, but that requires a pulsar, so I doubt we'll be seeing any intelligent life on such a planet like that.
Yeah.
But I don't know. It's very, very interesting. Where do we go from here? I mean, obviously, I would love to keep building bigger and bigger telescopes in space, but you also have the question: is there a point? And I was thinking today, is it possible that humanity could send humans to another star system? You know, like cryo freeze them or whatever. Send them to another star system, but before they even get there, humans have beat them there.
Hmm. I don't know.
Like, technology progressed so fast while they were gone that we developed warp drive technology, and so we were able to get there within a matter of days.
Uh,
And so the humans get there, and it's like, hey, it's 20 years into, it's 50 years in the future or whatever, something stupid. Oh, we beat you here. I don't. I would choose to hope that we would go and get them. We would go and grab them and then bring them home or take them all the way there or something. So, it's not just like wake up 50 years. Yeah, sorry, bro. You don't get all the fame to be the first humans on another star. You know? I don't know. That's what I would choose to believe, but hard to say. And I was thinking about, actually, I just thought about something. I watched a video and they were talking about solar panels. You still listening?
yeah. Yeah. Go ahead.
So they're talking about solar panels in space and how NASA said Jupiter is about the furthest we can push it with solar panels. They're like, we could consider Saturn as a possibility, but it would be really stretching what's currently feasible and what would technically is feasible for a solar panel. Beyond that, you have to go nuclear. And I was thinking about, what if there's these organisms, right, living in the methane pools of Titan? And I'm like, So if there's that little that little sun on at Saturn, so on Titan, and with Titan having an even thicker atmosphere, there's even less sun. Is chloroform, not chloroform, are chloroplasts sensitive enough to continue to make food so that some sort of living thing could use sunlight as a form of food? And I don't think so. What do you think? Do you think the living things on Titan will use the sun for food like plants do here on Earth? Or do you think they'll use something else?
No, I think I think there'd be some sort of photosynthesis going on, provided there's enough light.
But that's like, if solar panels are barely viable in the vacuum of space around Saturn, think about an atmosphere 2 times denser than Earth's. And very cloudy and just, it's not a good, it's very, ugh. I
Well,
don't,
so solar panels don't work there.
I, they don't work, they work around Saturn, not very well, but they can work. I just don't think solar panels would work on the surface of Titan, which makes me
No, they
think,
probably would. Yeah.
which makes me think they would be using like what those living things do at the bottom of the ocean around those hydrothermal vents. They use the geo heating from Saturn that causes Titan to get squeezed. The gravitational, oh god, the tidal forces from Saturn
Yeah.
to heat the planet.
Yes.
And I think they're to heat the moon. I think they'll be using those for as like photosynthesis.
That's heat.
Right. Well, things at the bottom of the ocean, they have no sunlight, yet there they are, existing, living.
Eating other organisms that are down there.
Right. All these organisms live and they have no access to sunlight. They don't eat organisms that have access to sunlight. They only eat organisms that are around these hydrothermal vents, which means that these things have to be there's a food chain. So there has to be so they're using thermal radiation, infrared light, as a way to make food, and then they are eaten, and then something eats them, and so on and so forth.
I guess the only thing is, Titan, does it have any volcanic activity? None, right?
I don't remember.
Because I'm just curious how life could have even started. You know, there's the first, I guess, characteristics of cells, that all cells are composed or created from other living cells. Well, the $1,000,000 question, where did the first cell came from? We have a vague answer for Earth, but that relies on volcanoes and lightning, storms. Have you heard this theory?
It's the primordial soup, right?
Yeah, you know, basically there are all these charges floating around, and lightning struck them in the middle of this lava heat mixture, and it more or less forced these atoms and molecules to bond to one another, and this chain of molecules that was created had carbon in it, which is the foundation of life, and it just so happened that this chain could reproduce from the
Yeah. So there are ice volcanoes. So yes, there is going to be heating.
But the thing is, I wonder if they still need energy from the sun to kickstart things.
I don't know, because another theory is that
Because
life
life,
started around hydrothermal vents.
yeah,
That's another theory. But I mean, you also have to think that, you know, life started here on Earth really quickly. The minute conditions were right, boom, life started. So it's like, if life can start here so damn easily, what's to say that it didn't start on Mars at some point? What's to say that it's not on Europa? And what's to say that it's not on Titan?
yeah.
Which is the whole what am I thinking? It's the Fermi paradox. What's the set of what's the probability for calculating extraterrestrial life? What's that equation?
The Dirac equation.
The what?
No, the Drake equation.
Right. And that comes from the Drake equation brings up what paradox?
Oh, I don't recall.
It brings up a paradox. Uh is it the Fermi paradox?
Yeah, yeah. Fermi paradox.
No, I don't want the game. I just want Fermi paradox. It's the conflict between lack of clear, obvious evidence. Yeah, so yeah, I was right. So it is the Drake
Yeah, so
equation.
Fermi paradox ponders why Earth has not been visited by aliens, and the Drake equation estimates how many intelligent civilizations are in our galaxy.
Mm-hmm.
And the Fermi paradox was like, well, if all these civilizations exist, why have none visited Earth?
Yeah. Maybe we'll discuss this in the fourth segment. This could be good. For the time being, we need to keep moving on to spare your voice.